everyone, and welcome to R&D Talk. This is a series of meetups where research experts and honorable guests from the industry share their insights on how technology, on the emerging technologies, on the newest technologies, and how they transform the businesses and impact humanity. This is the first session of 2026, so that's why we made this session to set the stage of everything that you should expect throughout this year. So, as you know, R&D is not something typical for companies like SoftServe, but at the same time, R&D exists for more than 17 years, bringing tremendous value for its growth and its customers. So today's session will be dedicated to the topic how to turn research into a compounding value and how to make it work on practice. At the same time, sharing what will be the bets that R&D made for 2026. Let me introduce you today's speaker, Volodymyr Karpiev. He is the leader of R&D director who leads the team that for all the time produce production-grade solutions and conduct top world research in Gen AI and other domains. He has extensive experience in 3D machine perception, AI. In his background, worked with the leading French machine perception startups and hold number of research roles at SoftServe. He has experience and hold degree in applied mathematics, nuclear engineering, and technology management from top European technical universities. As always, don't hesitate to ask the questions because topic is hot and there are a number of interesting insights, and all of those questions will be answered in the end of the session. Volodymyr, transfer word over to you and stage is yours.
Thank you, Bogdan, for such a kind introduction. Yeah, indeed, let's discuss today about R&D and about how we create this value for the company, for community, for academic community, and overall. Here, yes, today we'll discuss about different, with very specific examples of our projects, specific directions, what we do in research, and how we validate new business models, and how we scale the expertise. Once we identify this good match, what are these directions that we are scaling at the moment? Yeah, to let you know, at R&D, we work with this stage gate process, right? So we start experimenting. Still, exploration is the first step of scaling any initiative and building this compounding value. Stage gate process means that every 3 months we meet together, we present results of separate research programs. Each research program has goals, directions, technology stack, and we reassess them, right? Whether it makes sense to continue research or work or more applied experiments in this direction, or we should, for example, stop something and regularly start new initiatives to renovate and keep them updated. And yeah, so this is a process. And again, for this research and more open topics, it doesn't always make sense really to plan, to the same extent as you do on more shorter horizon projects, right? So we give more flexibility for research but with a specific, let's say, specific goals at the end of each gate that should be achieved, should be met, so that this research program moves to the next stage and to the next quarter. Among different research programs, we have fundamental research, also not the most common for service and consulting companies, but the goal of fundamental research is not short-term return on investment, not short-term commercialization, but it's rather investment in directions that we believe may work out in the horizon of 3-5 years, even if the market is not yet existent. In some cases, doesn't even exist. But there is a promising technology that improves exponentially or significantly orders of magnitude from year to year. So this is a good sign that it may eventually reach this moment in time when it will get adopted much more in the industry. So yeah, this is how fundamental research we treat slightly different from other initiatives. We put more long-term goals of development of new expertise. Conducting research should be validated externally. So one of the goals is that research is published, like it's not only published like internally or on company-wide websites, but it should be validated through peer reviews from the academic community, through like, I don't know, submission to the grants. It should pass the threshold of importance and significance, and also our depths of expertise within this direction. So we regularly publish and get this feedback from academic community on this fundamental research tracks. One of them is neuromorphic perception and processing. So to give a quick background on this one, you probably heard about Moore's law that guides computation. There is also Kumi's law connected to the Moore's law. The goal is to measure how quickly scale computation with respect to the units of energy that is dissipated, joules of energy dissipated. And so it's interesting that like both of those laws are starting to slow down slower. Also connected, similar reasons, like, right, you cannot do smaller transistors in some cases. So, but this second law, it slows down even faster. Kumi's law slows faster, which leads us to think that, like, to look for other paradigms, right? Like other paradigms that can help make computations efficient. And yeah, different approaches. One of them is like, right, to try to find like biological systems that are more energy efficient than hardware we build, CPUs, GPUs, other types of hardware. And then what such systems are, for example, in humans, right? Like again, it's really hard to compare CPU, GPU with human brain or other animal systems that can reason or can do decision making, can be involved in decision making and processing. But still, you can get inspired. So you can. This neuromorphic approach is the one is inspired from actual animal systems, like human systems as well, and has several components. One of them is that human brain functions fundamentally differently to how, for example, we build our neural networks or AI models at the moment. AI are heavily relying on convolution, which can be computed as matrix operation, multiplication of several matrices to achieve final result. What researchers agree is that human brain functions in a different way. It's more like a system that combines both digital and analogous type of computation. It is asynchronous, so there are no like blocks on matrices that can be just multiplied, but it's rather accumulation of signal, and then at some point it's firing through neurons or other systems, firing of the signal that is then further on the next levels accumulated. So it's highly asynchronous. I think there is no consensus about like digital or analogous type of processing. It's a mix of both. And also on the perception level is different. If you look on human eyes, they have two systems. One detect background and static objects and tracks them well. The other functions much better in to detect moving objects, right? Like if something moves in the scene, we directly see it, we directly spot it, and also adapts much better to changes in light conditions. And so those two ideas, one about perception, the other about processing, is the basis of neuromorphic perception. We experiment with this technology, and some of the premises of this technology, it's like, first of all, the sensor. The sensor here works exactly the same way. Compared to traditional frame-based cameras that take snapshot of the frame in regular like time frame, each 30 millisecond, faster or slower. Here, each pixel is asynchronous, counts the number of light that comes on its pixel, and fires once the threshold is met. And then again, there is hardware that functions differently. Intel is developing, by the way, their chips for neuromorphic processing. It can be also like this computation can be also done in more classical way, but then with specific adjustments. And so here we also experience the biggest advantage is that these algorithms are much more, and hardware are much more energy efficient. So one of the constraints, right, of the Kumi's law that is slowing down. It also works well. Each pixel that adapts well doesn't need to capture each time repetitive information. So it captures only changes in the scene, can react much faster than predefined frame-based like approach, like 30 millisecond, 50 millisecond, 100 millisecond. Its time resolution is even like in the order of, I think, millisecond, maybe microsecond. I'll need to double check, but much lower. I think closer to microseconds. And so we are experimenting with one of the cases. It's in food industry where like small crystals have to be monitored. They move really fast. Some of them move, the other are stopped. And so when we capture and also lighting conditions are very adverse and challenging. So capturing such scene with classical frame-based camera gives you like information that is very difficult to process. When you apply event-based cameras, you can much clearly see the crystals. You can then count the number of crystals, estimate the size, which is critical for the industry to assess the stage of this crystal's growth and take decisions based on this process. This is one of the examples, but applications could be also in automotive industry for building applications in automatic emergency braking, ADAS systems. Applications could be, I heard, like in mobile devices to help significantly make the image more crisper and more, let's say, to denoise and reduce the blurriness. So yeah, all this like we spent probably a little bit more time on this specific case, but it's one also of long-term researches. We are finalizing a paper to top-tier conference. I think this year it's ECCV, but yeah, we'll see eventually CVPR and all the others. And we'll also explore in parallel applications in manufacturing and in other domains of neuromorphic vision and processing. Another direction, another type of computation is quantum computing, quantum enhanced machine learning. So this is like the team, how to say, like the team is already well known at SoftServe. Like we have top researchers, we have teams that have been working on a number of projects before. At the moment, the team is focused on developing continuous development of the expertise, right? It's hard to predict any timeline, whether and at which point quantum computing will be like widely adopted or will reach this, like, let's say, inflection point. But still, we believe that for some of the cases, once this moment is reached, it will give significant advantages compared to classical hardware, classical software algorithms as well. We're actively developing expertise led by Christina Hnatenko. We like participate in industry events, in conferences, conduct like there are classes, courses for the universities that is led by the team. And another direction, like more fundamental research direction without very specific, concrete in time, let's say, without specific timeline for commercialization. But still, like there are new innovative offerings that emerge, innovative service offerings, innovative platform offerings, and we'll also consider these directions, right? How to contribute at the very early stages for the industry and try to spot potential directions for commercialization of this technology. Yeah, interactive AI. Interactive AI is another direction. So here at the moment we are experimenting with some of the brain-computer interfaces. Again, it's very early stage. I was even hesitating whether we should introduce it or not. So it's not yet validated as a long-term project, but still there are some interesting devices that were very noisy some time ago. And with introduction of AI, there is a big potential to make them work, let's say, more reliably, to extract signal better, and like bring them to the levels of stability that is needed for any practical use. It's very experimental. Of course, we don't experiment with invasive systems, so it's non-invasive brain-computer interactions, some other ways. But also the premise is very like significant, is huge. Imagine if some of those brain-computer interfaces work eventually, right? The whole interfaces of interaction, right, between humans and machines may change if like at the moment we understand front end as like part of the visual part of websites, right, and that with which we can interact. Like only imagination can lead us to what kind of interfaces may reappear if we fundamentally change the way we interact with technologies. So that's another direction we are validating at the moment. Beyond fundamental research, we also have applied research program. So here's the goal. The time frame is much shorter. We expect to validate this each of these programs within half-year duration. Most of the ones we'll talk today are already validated, meaning we develop some assets, build demos, specialize in a given expertise, and starting from some point, like, actually, it's encouraged since the beginning to validate this applied research directions with the industry with companies with whom SoftServe already works, with new potential customers whom we would like to work to validate whether this applied direction brings value. Of course, still very research heavy, still relying a lot on latest papers, latest technologies, released frameworks with which we experiment. But yeah, time frames for commercialization are much shorter, and the programs sometimes they get validated, the others we stop and start new ones. So that's important not to get stuck for longer than this, let's say, half a year duration, right? Like if the applied research conducted has huge demand, we see it quite early, and we saw it from previous examples. Like after 3, 4, 5 months, we already see that customers are interested. This is on their radars already. Example of such kind of applied research is life science, and I would add also healthcare. So this is the direction we have been working for some time. There is strong demand. Also, it's a good overlap with a big cluster, big part of, let's say, delivery and customers of SoftServe that are from this healthcare direction. But we are also experimenting with new directions in drug discovery, in like, I don't know, optimal dosage of optimal treatment strategies for patients, and many, many others. So relying again heavily on cutting edge research advances through AI, and also machine learning, more classical ways are also often applied in this domain. And yeah, we are also open to partnerships to help to prioritize some specific use case partnerships with, let's say, universities, academia, to help identify the directions that, like, emerging directions in healthcare. A visual Gen AI, it's this one was like, I think was one of the examples of the programs that have got commercialized really, really fast. After a few months of experimentation, early customers were interested in such solutions. For example, everything related to generation of images, of videos. This was like, now the technology becoming better and more accurate, more precise. But during the early days, generation of such assets were not accurate, right? Like there was lots of noise, blurriness, humans inside. Like sometimes we need to generate humans also as part of this image, had a lot of artifacts and hallucinations, let's say. And so the goal of this research program was really to take some of the state-of-the-art models and build pipelines, custom pipelines around them, pre-processing, post-processing, adjustments, specific blocks, computer vision based often, that significantly improved accuracy and performance of generated assets. And so yes, this is a very good example that started from research papers, even master theses. And quickly after validating, building initial demos, it was clear that there is strong signal, and the program scaled to like big part of AI initiatives that we are driving at R&D. AI platforms, so that's another direction, strong signal from the industry. Companies are looking into building their own AI platforms, agentic platforms often. Such platforms are still, like, to build such platforms, there's open questions on building connectors, on how these agents should interact between each other, how to build guardrails, ensure safety of the agents. Open topic of research. And so building such AI platforms, both for the customers internally at SoftServe, became another applied research direction with, like, huge interest. Multiple customers are interested in exploring the solutions and best practices that were developed during this program. So we are continuing to scale this one. Again, feedback. Like, I think actually we initially had requests on such AI platforms, expertise, and then initiated this program. So like we can say that it was commercial, like, let's say, assets built during this program were commercialized like almost immediately as we are going. Hardware lab. So that's another topic. So we don't do only software, even software, new paradigms of software, but we have very strong hardware labs that works with different types of hardware accelerators, hardwares like classes of virtual augmented reality. We have experts who can program them, build software dedicated to this type of hardware, right? From one perspective, it's acceleration of algorithms on those often embedded or limited resources that are available. But from the other side is also like covering the whole cycle because, for example, this AR, XR glasses, right? You need expertise in multiple directions to work with glasses, starting from optimization, programming of hardware, streaming, audio, video analysis, image analysis, AI models. All this is part of expertise that is needed to work with the hardware and to build solutions there. So this full cycle of expertise is covered within hardware lab as well. I'll share some more specific examples of how we work, for example, with GPUs from NVIDIA and other embedded devices, because that's actually one of the directions that we see a lot of interest, like interest on a big demand for expertise, a lot of interest on deploying algorithms, not only AI algorithms. We'll talk about it in a while. Physics-informed neural networks. So another important direction. So there are simulations. Simulations sometimes in classical way take too long, right? You need to wait until the simulation is finalized. It will be much more precise. And the goal of this program is to accelerate such type of simulations. Sometimes accelerating it by several orders of magnitude. How it is done? This is done by simulation by let's say reformulating the problem of simulation, right? Like often you have a list of constraints that are formulated in the form of partial derivative equations. This system of equations can be reformulated as an optimization problem. So just from mathematical perspective, turns into optimization, and then optimization problem can be solved with neural networks. And some of the examples, and we have shared research published with Shell, for example, where some of the processes in chemical reactors were accelerated by orders and orders of magnitude. I think it was some of them by 6 orders of magnitude, meaning 1,000,000 times. But also there are researches in analysis of airflows, in researches in propagation of certain like methane emissions or other types of gases in the atmosphere, which are like important for the energy industry. So yeah, this one has steady demand, and also frameworks. Like previously, it was called Modulus from NVIDIA that helps you build physics-informed neural networks for specific problems. They also have some use cases. I think now it's part of their more like this AI machine learning platform. So they changed the name, I think, recently. But also a very powerful tool to accelerate not all, but specific type of simulation. One of the, let's say, important aspects are that simulation become approximate. So you don't have full precision. You save a lot in time needed for simulation, but you may lose, depending on the type of use case and the setup, you can lose from several percents to more in accuracy of such simulation. So not like, let's say, the same precision like accuracy, recall, whatever metric like makes sense, but significantly faster accomplished compared to classical simulation. By the way, also interest from automotive domain on accelerating some of their simulation cycles on powertrain and gases, liquids that are there. Audio direction, and again, the name is unifying. It's AI audio, but by AI audio we mean also like signal processing, also spatial audio, also like different types of audio, different applications of audio, from healthcare, from like that's dyslexia detection in young children to other like more signal processing, speech to text applications, and many others. Here's the idea is that we have really strong team covering audio expertise from different aspects, from different domains. Also now, of course, applying AI models to analyze the signal, to build spatial models, to reconstruct this signal propagation in environments more accurately, taking into account geometry of the environment, geometry of the room, materials of the room, there are several projects in process. We have built also like this speech recognition platform, the one as SoftServe IP, intellectual property, that was also used for several projects and to specifically recognize speech in children, right? If you can imagine this classical like AI models that are available, they were trained on the data, and there is lots of data available for adults, while children are much less represented in these data sets, and also elder, like let's say adults, right? They may have some very specific both of those groups may have some specific details of pronunciation, and so if not enough represented in the training data set, then the model will as well not how to say will not have the same performance on such type of recordings. So the goal here was really to target these edge cases of the models for specific applications like dyslexia detection or improvement of signal transfer through how them called like police talking devices, right, when they discuss between each others, and some specific edge cases like this, but still needed for practical applications. So yeah, these are several applied researches, and we are talking about them today. But like in a quarter or in 7 months, in 6 months, or in a year of time, many of them can be like updated. Some new programs will be started. Some of this will be put on hold. Also at R&D, we're experimenting with IP initiatives, with the ones where SoftServe develops intellectual property and then either licenses them or experiments with other, let's say, commercialization models. This is very early stage, so we are still experimenting with it, exploring potential types of engagement, trying to identify the repeatable use cases where the same, let's say, solutions or accelerators can be reused for several, let's say, customers. And so this also active process of like prioritization, review. Timeline is also often like half a year, sometimes maybe up to a year to validate AP initiative. Difference compared to applied research is that you need actually to invest a lot of work in building a solution that can be shared as is with the customers. It's not only like research algorithm or the technology that outperforms available solutions, but it's also user experience. It's the applications that should be built. A lot of things to think about, a commercialization model, which takes more time. So, but still, if done well, can scale very well as well. And we might not go into all the details of the solutions stopped in validation or active. Like for the active ones, it's like content creator, QA agent, AGI kit. By the way, AGI kit will be presented at AWS event, a major event soon, so that all attendants will be able to use it and see the advantages of AI deployed on edge devices. And modernization, like set of agents for modernization projects. Once again, licensing is one of the potential approaches that we are validating, but there may be other approaches from business perspective. And also, once we identify this repeatable assets, very important topics will be on patenting, on defending this intellectual property, and let's say preventing them being how to say like transferred, open sourced, in order to like make them repeatable for the customers. Okay. So this was like the topics we just covered. Those are research programs. Those research programs are experimentation with new technologies, new research papers that are coming from technologies, new research papers. But one of the goals of R&D is really to build up this knowledge, stack it, understand whether there is a need for such expertise in the industry, validate it there. And if all these aspects, right, like there is advantage within SoftServe to develop it, there is demand outside, customer demand, we have required expertise, we know the technology, and technology readiness is also an important factor. So all these factors match. The end goal is to identify the expertise that should be scaled, that is repeatable, and that we can formulate as repeatable service offerings. For this one, we see a big demand for three directions since the beginning of 2026. The first one is around embedded development, high performance computing. So, already mentioned briefly before, projects like from video conferencing to network security to development of cross platform support, embedded SDKs, all those are in high demand. Again, sometimes related to AIs, but often just more regular classical algorithms that should be deployed on constrained resources, on constrained hardware. Could be different type of hardware, but let's say this is not like the kind of cloud processing with almost like that can be scaled much faster. So these are smaller devices where there are specific constraints, either throughput, latency, other aspects should be taken into account. GPU is a big part of such devices. So GPUs, there are, if let's say huge part of the industry is optimizing, reducing cost, energy efficiency for AI models, lots of algorithms can benefit from GPU acceleration as well. From energy domain, from I don't know, weather forecasting, other directions, and such algorithms don't get always enough attention. And understanding the architecture of GPUs, knowing CUDA programming, like let's say best practices, language, other ones applied for GPU, is like is critical to make them run efficiently on GPUs. Several projects are described here. I'd like also to mention that not only GPU. GPU is not the only hardware accelerator anymore. There are many companies define this as part of their priorities to introduce new hardware concept, new hardware platforms. For example, Amazon is having their Graviton, with which we also are experimenting and are benchmarking to understand its capabilities. So yeah, both directions is important, and we'll see even bigger traction, more interest in such, let's say, diversification of hardware platforms, hardware acceleration beyond NVIDIA GPUs. The second direction is about AI solutions. AI solutions and building them for the customers. I think here our biggest advantage is that we are really building production-ready solutions that have either like significant return of investment for the customer, significant cost savings, or as like are like act as a differentiator for them. They're introducing new features that are not available, that their competitors don't have, and they are targeting right like big usage, a lot of users of their applications. And so here also like we have very good examples of platforms that are used by millions of users monthly. Here are a few examples of such AI solutions, right? Like despite hallucinations, despite not perfect stability, despite probabilistic nature of AI models, we still manage to, like, let's say, position and reduce this uncertainty and deploy them in production for the customers. The first one is when we experiment with low-code platforms, providing actually professional services for one of the platforms that is then deployed for like customers, like worldwide known customers, and have adapted this agentic platform for them. And very similar requests about other AI platforms are appearing from many customers at the moment. The second one is specifically around visual Gen AI we previously reviewed. So here the team have built solutions that helps understand materials on the images, helps improve quality of the generated images, assets, 2D, 3D assets. And their application is used like had multiple over 35 million downloads and also I think millions of users monthly. I mean, this is part of the functionality of this application. Of course, there are other features, but this Gen AI feature had a huge success. And by the way, it was publicly announced. This project was publicly These features were publicly announced more than a year ago with SketchUp and Trimble at their annual conference. Also, healthcare assistants in production have significant potential to reduce the costs. Lots of paperwork, like nurses do lots of paperwork that take a significant fraction of their time. And when deployed at scale, once again, carefully deployed without like increasing the stability of the solution, right? When we know which data we take as input, where this data should be, let's say, outputted, right, to which table, which cell. In these cases, we can significantly reduce the time spent on paperwork and eventually improve, like, let's say, reduce the cost of operations for such healthcare institutions. Yeah, one more case. We'll not probably go through the details of architecture or like, let's say, context, outcomes, use case, but I like this case a lot here, like probably even more than 3 million monthly users, very like well-known platform assistant. Again, help to significantly improve accuracy for such platform. And as a result, like, users really love using this functionality. And so this is like first, just to recall, it's embedded processing and high performance computing. The second direction is building AI solutions despite hallucinations, instability, and other, let's say, limitations of the language models. And the third direction is agentic engineering. That's really important direction, I think, really for both internally within SoftServe for the customers, as the use of agents in while developing code, writing code for the engineering. Again, agents, they don't solve everything, right? It's not a magical button that can deliver the project or make it end to end, right? There are specific parts of the project when it can be very valuable, significantly reduce time needed or accelerate the development. And yeah, so from my perspective, agents, like whether there is better use case or worse use case, I think everyone should learn them, should experiment with them, should form their own opinion on how well they perform in those use cases, right? Because the technology, it's one of so-called exponential technologies that is improving from year to year. And so if some of the use cases are not the strongest today, they might significantly improve in a year of time or in 5 years become become very well accomplished, with agents using language models and can act either on the code base, right? Or perform other tasks. And so here are a few case studies. This one is around agent that accelerates significantly C++ modernization. Again, agents could be customly built for specific projects. Agents, there are agentic tools that are available, like Cursor, like Devin, like other very, like, let's say, capable ones, right? Like that you can use and you can learn from it, and you can, there is a whole concept of this agentic engineering. In my opinion, it differs a lot from typical SDLC, but the difference is in the nature of the tools that are used, those agents, right? They're probabilistic, they're not stable, they don't always work. And so part of this SDLC should adapt to the strengths and to the limitations of the agent that we have at the moment. Some parts they can accelerate significantly, so there is no need to spend that much time maybe as before on such parts of SDLC. But from other perspectives, they need to be checked and you need to iterate with them sometimes more. Maybe in some cases, you don't have to write code line by line, but you really need to adjust the agent, spend time to improve the quality of its outputs, and eventually use to accelerate the remaining part of the project. Yeah, here on we accelerated C++ modernization. Another case where there was a significant reduction of, let's say, we significantly reduced estimates for modernization project from Groovy to Kotlin modernization. Overall, modernization projects are a great fit for such agents because for modernization, you have a previous project, let's say a legacy project, and you have all this constraints, logics that you can extract from it. It's like it's context that you can pass to the agents or to the language models based on which they can then plan or execute modernization of the project and build the new one based on all these constraints. So they're in a way specialized in the form of this project or old legacy code base. So that's a big advantage. And also testing in specific testing cases, AI agents can also bring big value. What we observe is that we don't advise, like really applied out of the box these agents on just code base, but often inputs from humans are very important in the form of, let's say, test cases. If the test case is well defined, well specialized, if, for example, junior engineer can follow them, so then the agent may follow as well. But when inputs are not clear, when um, testing flows are not well specified and documented, test cases are not of good quality, then the agents will also have, let's say, hard times to execute on those. So this was mainly it. To summarize, we experiment a lot at R&D with new technologies. Once we see a great match, when technology is ready, when there is demand, there is a real problem in the industry, in the business that this technology can solve, we are among the early adopters who build solutions, who adapt them for the customer needs or for the industry needs. And based on this, we start building this compounding value, finding repeatable offerings, and scale this expertise within SoftServe. If you have any questions, feel free to drop them in the chat or like write. This is probably the typical flow. I know that there was one question before we started that was shared. It was more about funding of Ukrainian university lectures, how they can obtain funding for research and development. And again, so this was not like specifically topic of this session, but also like we have researchers working at R&D and sometimes we attract like additional funding through grants at R&D. So basically, my understanding is that there are grant programs, both from like here is mentioned specifically Ukrainian university. So there are grants from Ukrainian government, there are grants from European Union organizations in Europe to which you can apply. Of course, there is like specific set of requirements. Sometimes the process is really not straightforward. Sometimes you need a consultancy agency, like there are other specialized consultancy agencies that you can request services, right, to prepare your application. And based on this, you can get funding for specific directives in R&D, in cutting-edge technologies. And this, in my understanding, how majority of research R&D project like research tracks work in Europe. In Ukraine, again, I don't often hear like it's probably not yet so common to get this to participate in European grant programs, institutions, but and again, there are a lot of questions, pitfalls, and stuff. But this is, as I hear, like one of the most common ways to fund new research directions. And by the way, yes, at SoftServe in the company, we also were participating in several grants before. So for a new ways of interaction, like there were several topics where we participated in such grants, and also it's great opportunity to develop cutting edge expertise and let's say expand your capabilities in specific directions. Some of the grants are also even long term, like 3-4 years of development. And big advantage is when you have partnerships, when you join this grant proposal together with like as a company, of course, we have this engineering part, engineering capabilities, also research, but often applied research. And we partner also with other more fundamental research institutes, research groups. And typically those are consortiums of several, 5, 10, sometimes I saw even like around 20 participants of such consortiums that apply for grants.
Great, great. Thank you, Volodymyr, first of all, for the informative presentation. As you can see, we also have in our chat one more question from Bogdan. So I will read. Do you have any R&D for platforms like Salesforce?
Well, like Salesforce, probably not, but yes, we are building platforms within R&D, within SoftServe as well. The goal of the platform is also one of the types of assets, repeatable assets that you can then reuse on projects to accelerate development, to provide these capabilities for the customers to build on top of. There are platforms around agentic engineers, there are platforms like AI platforms, there are like several types of the platform. So this is like kind of one of the type of assets, one of the type of IP initiatives that can accelerate most often this in case of repeatable research programs, repeatable service offerings like three that I mentioned before. So this is like, I think the biggest focus is building platforms and IP assets in embedded HPC, AI, AI feature development, AI products, and agentic engineering.
Thank you. Thank you, Bogdan, for your question, and thank you for answering, Volodymyr. Colleagues, maybe do you have any other questions? So feel free to unmute yourself or text in our chat.
Yeah. By the way, one more comment. So, as we are scaling now those three directions, we have lots of open vacancies. There are internal people can join internally from SoftServe. We have open external vacancies. So directions from agentic engineering, AI product development, and embedded embedded HPC also important requests. So if you guys have relevant experience, if you want to learn also, or you have some previous experience, don't hesitate to reach out. You can reach out to me directly or respond to some of the vacancies or reach someone from the team if you have some contacts. We can help you understand what is the match, what is the fit. So please don't hesitate to reach out to discuss. Maybe then as a result we can come up with next steps that you can take to, let's say, come back even more prepared in several months, or maybe it's already can be a fit, for example, for agentic engineering, because we are looking for strong engineers like full stack, front end, back end, the ones who have really strong experience in engineering. Then agentic experience with agents, it's not something that requires half year of learning or studying. So this one I think you guys can get up to speed very quickly. So don't hesitate if you have interest in developing in that directions.
Great, thank you, Volodymyr. Also, we have from Vladislav one more question. Are QC engineers involved in hardware projects?
Directly, depending what, if you're by the way, we had some projects when we were building hardware. We have some projects when we program hardware. This is one of the directions. If for agentic engineering, it's onboarding programs, learning of using the agents, and you're good to go. I think it's a bit more, even more specialized for hardware projects. You need to know have understanding a bit of the hardware. You need to understand low-level development, how to analyze profile algorithms, how to deploy them, how to rewrite them, how to, I don't know, again, and how to review memory footprint, how to review I don't know, understand latency constraints, anything else. So if you have relevant previous background, we are actively looking for candidates. It's really tricky to find people with this specialized knowledge. Even so, in Ukraine now, this gains a lot of traction, embedded programming, robotics, and drones. But still, if you have high-performance computing, if you have expertise with CUDA, with GPU, please don't hesitate to reach out. We'll definitely find a way to, collaborate and involve you in projects, either now or maybe you have priorities on your ongoing projects eventually, during the year.
Also, Vitaly is adding, what about DevOps, DataOps, cloud infra engineers?
Super important. We are most commonly we involved with DevOps practice at SoftServe. All these agentic solutions, deploying the agents on customer side. We often need people with background in deploying such models, in monitoring them, and all the kind of work that DevOps typically do. So we typically share requests to our practice, and then we identify candidates that can join specific projects. From the perspective of agents, I don't see I think there are from Prometheus and Covenant perspectives, those are two big initiatives, agentic initiatives within the company. So there are also approaches to build agents around DevOps part. But we definitely need people with this background. It's just if you have preference, interest in any of those topics, feel free to reach out. But we actively work with DevOps on the projects.
Great. Thank you, colleagues, for your questions. Maybe someone want to add something. If no, we can wrap up. Thank you all for joining today's session. We truly appreciate your time and engagement. A big thank you to our speaker, Volodymyr, for such an insightful talk. Colleagues, if you have any questions, feel free to reach out to Volodymyr directly. Stay tuned and visit our site for more detailed information and updates. Looking forward to see you. Bye.
Thank you. Thank you all for interest at R&D. Yes. Let's stay in touch. Bye-bye.